Welcome to a video on evaluating the composition of functions. For this problem, we are given two functions f of x and g of x. Find the following. For part A, f circle g of x is defined as f of g of x. And so we'll start with the inside function, which is the g function. So replacing that with 1 over 2x plus 1. And now we're going to evaluate the outer function at this expression. So given the function f of x, that is defined as 6 over its argument. So 6 over the argument is replaced with the ratio of 1 and 2x plus 1. And now simplifying this, to divide a fraction, remember, is to multiply by the reciprocal. So reciprocating 1 over 2x plus 1, we get 2x plus 1 divided by 1. Now make sure the 2x plus 1 is in parentheses because that is the entire denominator of the g of x function. And now to simplify this further, we can distribute the 6 through, which results in 12x plus 6. And that is the composite function of circle g of x. For part B of the problem, evaluate g circle f of negative 1. So by its definition, that's g, evaluate at f of negative 1. Again, we'll start with the inside function. F of negative 1 means that we're going to replace the input value on the function f there with negative 1. So the outer function is still there, so g of, and now 6 divided by negative 1. Simplifying 6 divided by negative 1, we get a negative 6, and then plug this number now into the function g. So using the function g, that's 1 over 2 times negative 6 plus 1, and then further simplify this, we get 1 over negative 12 plus 1, which is negative 1 over 11. Consider another example on evaluating compositions of functions. For this problem, letter A, g circle f of x. Again, by definition, that's g of f of x. Similar to the previous problem, we're going to start out with the inside function, which is the square root of x minus 4. Evaluating the outer function at this expression. That's the same as saying 2 divided by. The argument of the g function is now replaced by the square root of x minus 4. And now simplifying this, we're going to rationalize the denominator. So multiply the top and the bottom by the square root of x minus 4, which simplifies into 2 times the square root of x minus 4 all over x minus 4. On letter B, we have g circle f of 0. So again, by its definition, that's g of f of 0. We'll start with f of 0. So f of 0 here is replacing the argument of the function f with 0, which is going to give us the square root of negative 4. But note that the square root of negative 4 is not a real number. Therefore, g of a non-real number is undefined. Now let's consider part C of the problem. Find two functions, p of x and q of x, such that the composition p circle q is the function f of x. Let's recall what f of x is from the original problem. F of x here is defined as the square root of x minus 4. So f of x is a composition of two functions, p and q, so that when we evaluate p circle q, we'll end up with the function f of x. So this is equivalent to basically saying that it's p of q of x. We can see that the inside function is q of x, and therefore the outer function, if it is the square root of x, then the argument of p of x has to be the radicand. And therefore, to answer this question, if p of x is the square root of x, what is q of x? Q of x would have to be the radicand, which is x minus 4. So if we were to evaluate this, p of q of x, we would have p of x minus 4, and based on the function p of x, replace its argument now with the quantity x minus 4, which is the result of f of x. And therefore, that is one possible solution. Another possible solution is to start with an expression that defines the inside function of this composition function. So we can say, let q of x be an expression, let's just say x plus 3. Then plugging this into the outer function needs to result in the square root of x minus 4. And therefore, if I were to replace the argument of the outer function with x plus 3, I need to make sure that it's going to result in radicand of x minus 4. So basically, x plus 3 under the square root plus what value is going to give me the radicand of x minus 4. To make this a quantity of x minus 4, I need to basically add a negative 7 to that. And therefore, p of x here would have to be an argument x plus a negative 7. And now replacing its argument with just the simple x, you can see that that would be the outer function had q of x been the expression of x plus 3. So let's verify this. If we were to evaluate p of q of x, we'll start with the inside function, which is the quantity x plus 3, and now replace the argument of the p function, which is x here, with this expression, and then complete its operation by adding a negative 7 there. And therefore, under the radical sign, you can see that combining like terms, we have x minus 4, which again is the function f of x. So this is another possibility to create a composition of two functions so that when we evaluate p circled q, we'll end up with the function f.